All right, welcome to the world of, yeah. Welcome to the world of PowerPoint presentations, I guess. So we're going to go through the PowerPoint. Piecewise functions is kind of what we're looking at. So this is section 1.3, what we call piecewise and step functions is what we're going to look at kind of in this unit. So just a couple things that you'd probably know that you should know how to do already, or you could just do right on Desmos. We could make these graphs just for kind of review of what these graphs look like. And I said you could go ahead and make these graphs kind of on Desmos as far as things go. So if at this point you want to go ahead and do those on Desmos to see what they look like, you can certainly do that. And what you're going to see is you're going to kind of see a couple absolute value graphs. The first one, you'll see what they do if you graph those right on Desmos. I'm not going to show them so much as what they would look like. So what we're going to do today is we're going to both solve and graph what we call piecewise functions. So up to now, we've been looking at functions that represent single equations. So y equals 3x, y equals 2x plus 4, and so on. Those are just single equations. In real life, however, functions are represented by a combination of equations, each corresponding part to its different domain. So if you think about sales, for example, or not really sales, or maybe you're going to go buy something, and if you buy 5 pounds of something, it costs you this much. And then if you buy over 5 pounds, that price reduces, and then your graph's going to kind of slip down a little bit, and it's going to cost you this much. So you've got a given span that you have to pay for $1 through $5, and then you have to pay something else for over $5. It's kind of how the tax system works. The tax system, when somebody tells you have to pay taxes or you're in this tax bracket, what happens with taxes is everybody pays the same tax rate for this first amount. So you pay whatever it is, maybe 11% or whatever it is, until you get to $50,000 or whatever, $25,000. And then everything after $25,000 is taxed at a different rate. So if you make $24,999, you're getting taxed at 11% for all of that. If you make $28,000, that second tax bracket, then everything over $25,000 is going to be taxed at a different rate. So $25,000 would be taxed at, say, 11%, and then $3,000 would be taxed at whatever that next percentage, 12, 13, 14%. It's kind of how taxes work, and they're kind of what we call piecewise functions. They change as our X value, so to say, as our money value changes. And these are what we call piecewise functions. So piecewise functions kind of change kind of as you're going along that x-axis. So by definition, a piecewise function is a function that is a combination of one or more functions. The rule for a piecewise function is different depending on the parts or piece of the domain. So what you pay on the first $25,000 in taxes is different than what you pay on the next $3,000 in taxes if you're over that $25,000 barrier. Another example is, for instance, movie ticket prices are often different for different age groups. So you would have a function for kids. If I buy 5 kids tickets, it's going to cost me this much. But if I buy 5 adult tickets, it's going to cost me this much. So different values for different ticket prices based on kind of that age group. So this is an example of what a piecewise function would look like. So we've got f of x is equal to 2x minus 1 for all x values less than or equal to 1. The function then changes to 3x plus 1 if x is greater than 1. So you're going to deal with one equation and find its value of f of x when x is less than or equal to 1. And then you're going to use the other when x is greater than 1. Okay? So then we can take piecewise functions and we can evaluate piecewise functions. So we're going to evaluate this piecewise function at x is equal to 0, x is equal to 2, and x is equal to 4. So now the function changed from last time, from the last slide. So our function is f of x is equal to x plus 2 if x is less than 2. And our function is 2x plus 1 if x is greater than or equal to 2. So our function is changing depending on what our value is for x. So the first thing you have to figure out is you have to figure out which equation you're going to use. And you're never going to use both of them. You're either going to use the first one or the second one in this case. There could be tens of these that you could use possibly. But you can only use one of them. Okay? So if we look at x as 0, x of 0 fits this one. So that means that it fits into the top equation. So what that means then is we're going to go ahead and substitute 0 in anywhere we see an x, just into that top equation. So in this case, our function f of 0 is going to equal 2 because we had to use that top function. If x is equal to 2, that fits the bottom one because it's greater than or equal to 2. So anywhere in that bottom one we see an x, we're going to replace it with a 2, and we're going to go ahead and solve. So 2 times 2 plus 1 is 5, so f of 2 is 5. The 4 then falls into the bottom one as well because it's greater than 2. So now anywhere we see an x in the second equation, we're going to replace it with a 4. So 2 times 4 plus 1 is equal to 9, so f of 4 is equal to 9. So again, the first thing you always have to do with these is you need to figure out which equation you're going to use. You're only going to use one of them. And the one that you're going to use is where what you're trying to evaluate falls, right? So then, of course, we can graph these as well. If you can evaluate them, you can graph these as well. So if we look at this one, if we're going to graph this, for that top one, for all x's less than 1, we're going to use the top graph. Okay, and we're going to make a graph out of it, and we'll show you how to do that here in a second. And then for all x's greater than 1, you're going to use the bottom. And then all of those graphs are just going to be to the right of 1, kind of on that number line. So if we look at what this graph would look like, the red one is the top graph, is the x equals, okay, so let's go to this because that's what I put in there. So x equals 1, that's kind of the breaking point. Okay, our graphs, each of those graphs is never going to go over the 1 because we have less than 1 or greater than or equal to 1. So that's kind of a breaking point, is right at that 1. The right-hand graph then is the one that's to the top and to the left. And you could graph that any way you wanted to. You could put it in slope-intercept form. You could pick a couple points. My suggestion when you're doing these is to just pick a couple points. Pick a point that's way off to the left. Maybe pick x is equal to -10. Find the y value. And then I would actually pick one of the points on the line. So I would say 1, and then figure out what your y value is going to be if you do that, and so on. To the right, that's our bottom equation. And again, notice they stop in those spots, and that's what that one's going to look like. And again, they can't go past that break line because they don't exist. The red line doesn't exist to the right-hand side of our break line. And the blue one doesn't exist to the left-hand side of that, kind of that break line. All right, so let's say we're going to graph this one. Okay, and because I know what's going on, this is going to be, there's a little bit of a break in here, so I'm going to have to take, we're not going to actually graph it on this one because the PowerPoint slid it over and messed it up for some reason. So don't pay attention to this graph at all. This graph is kind of wrong. So if we're going to graph this, I'm going to graph kind of this top one first. I'll put my graph down here. Okay, so in my first function up here, it's all x values greater than 2. So I'm going to pick 2 x values. I'm going to pick f of 2 to find, and I'm going to say let's find f of 5. Okay, so if I replace a 2 in there, I've got 2 minus 1. 2 minus 1 is 1. So I know on my graph I've got the point 2, 1. So my line here that I know I can't go past is 2. Okay? And I'll graph this first one in, let's do it in yellow. So I've got the point 2, 1. Now it can equal it, so it's going to be an open circle. Now I'm going to put it in there as a 5. And I can, because it has to be greater than 2, I know I can put a 5 in there. So 5 minus 1 is equal to 4. So now I know I have the point 5, 4. So 5, 4 is another point on my line, and my line's going to go off kind of in that direction. Okay, so that's the first function. My second function, now I have to pick values that are less than or equal to 2. So I'm going to pick 2 again for it. So now if I pick 2 for it, I've got negative 2 plus 1, which is negative 1. So I've got the point 2, negative 1. So 2, negative 1 is right there. And this is going to be a closed circle because it can equal it. And now because this is all x values that are less than 2, I'm just going to pick 0. I can pick any one I want over there. So that's negative 0 plus 1, which is 1. So now I know I've got the point 0, 1. So on my graph, 0, 1 is right there. That goes off in that direction. So that's what that graph is going to look like. And again, we've kind of got this line in here that it can't cross, or those can't cross. So you either got to have an open circle on that line or a closed circle on that line. Closed if it can be there, open if it can't. Okay. Now, again, this graph is a little bit wrong. That point, that line is kind of what we call the line or point of discontinuity. It's going to change depending on what it is. All right, so that's piecewise functions. The next thing then is what we call a step function. And a step function is exactly what it sounds like. It's different functions that kind of make this stair-step effect. So in this case, f of x is going to be 1 for all values of x between 0 and 1. 2 for all values between 1 and 2. 2 and then 4, and so on and so forth. So what this graph would look like is there's the first one. It just goes from 0 to 1, and it's a closed circle because x is greater than or equal to 0, but it's less than 1, so we've got an open circle. The second one, if it's 2, the next one if it's 3, and the last one if it's 4. This is considered to be a step function, and step functions happen quite often when you're talking about kind of age groups. It's going to cost you this much for this age, this much for this age, this much for this age, and so on and so forth. And that's what we call kind of that step function, and we could graph that if we wanted to, and so on and so forth. Okay, we don't worry about ceiling functions and step functions. We don't care about those. We don't really worry about them as well. So that's piecewise functions and step functions. Let's go ahead and evaluate a couple piecewise functions again, just kind of some extra examples, and we'll go over these as we flip through. So again, evaluating piecewise function is just like evaluating functions that you already know how to do with. If we want to calculate f of 2, the first thing you want to do when you calculate f of 2 is you need to decide which one of the two functions that it belongs to. 2 is greater than 0, so that means it needs to go inside of that function. Then anywhere I see an x in that function, I'm going to replace it with a 2. Okay? We substitute it in there. 2 minus 1 is 1. That's the evaluation of that piecewise function. Okay? If I evaluate f of negative 2, again, we look and see where does negative 2 fall. Negative 2 is less than 0, so it falls in this function. So then anywhere I see an x in that function, I'm going to replace it with a negative 2. We go ahead and solve that. We get 5. So f of negative 2 is equal to 5. Okay, so now it's kind of your turn. Okay, we're going to evaluate these, and I'm not going to show you the answers yet because I want you to evaluate these 5. I'll go ahead and edit the video now and put about a minute and a half, 2 minutes of fill inside of the video right now, probably of me running or doing something strange. I don't know, probably me running because that's really all I ever do. But go ahead and figure these out. so there are your solutions. So see how you did. Hopefully you got them right. Yeah. Again, so f of -2, if we look at this, if we got f of -2, -2 is less one, so that's going to use the first one. 5 is bigger than 0, so you're going to use that one for that one. 0, it is 0, so you've got to use that bottom one because that's less than or equal, and 1 is greater than it, so you got to use that one. Okay? So let's try it again. One more. Ooh, now there are 3 of them with different values for them, so that's okay. We're going to do the same thing. Find out where they go, plug them in there. We'll do a little fill here. I don't know. I'll put something in here and see if you can find the answers. There are your solutions. And again, kind of real quick, -2, figure out where -2 falls. -2 is going to fall into this second one because of this greater than or equal to sign. So anywhere you see an X, you're going to replace it with a -2. If we look at the 3, 3 falls, 3 is greater than 1. So it's going to fall into this one right here. -4 falls into that one because it's less than -2, and 1 falls into this last one as well, so that's where you should have been plugging it in to get that one. All right. That does it. So your homework for today is a Schoology worksheet. Yeah, so go inside of Schoology and open up the piecewise function worksheet. You'll have to graph some of them. You'll have to do other things with them. Kind of as well. So have a great day. I think I'm doing this one on a Thursday. I think is when you're going to watch this one, is on Thursday. So got one more day. Tomorrow, I don't remember what it is. Oh yeah, tomorrow is a good one. Tomorrow we're actually going to do a live lesson. Tomorrow's lesson is on solving systems of equations with 3 variables. So tomorrow is something brand new. And each problem takes quite a while. And if you make a mistake on the problems, they take even longer. So tomorrow's going to show some patience with you. You're looking at probably 5-6 minutes per question tomorrow. And if you make a mistake in the first 30 seconds, you just wasted 4 minutes and 30 seconds. So tomorrow takes accuracy and patience when we're solving these. So get done with your Schoology worksheets. We'll talk to you tomorrow. On a live lesson. If you can be in on the live lesson, make sure you are there tomorrow, either at 8:30 or 11:42, one of those 2 times.